How you doing? Prankster Man here. This is part 2 of 10SI, 12SI teardown, rebuild, and testing of these alternators. I know I said I was going to do this in 2 parts, but time was running a little long. I figured out might as well cut it and then add another part, so there's going to be 3 parts of this. This part I'm putting the rest of the alternator together, both 10SI and 12SI. I'll show you the wiring, how to wire them up to where you could use 2 wires, which would be a battery wire and an ignition wire. Yeah. Okay. So let's get started. Okay, I'm set up for testing. I basically just got a digital ohm meter. It's set up for resistance, straight resistance. Right now the one shows resistance, and when you hold the leads together you got no resistance. Let's start with the rotors, testing the rotors. Test the rotors, you basically go from one slip ring to the other. Should show no resistance, which would bring the number down to 1 or to 0. You let go and then you touch the shaft. You make sure you don't have a connection from the wiring in the magnet to the shaft, which would be a straight ground, which would short out the alternator. So this one's good. You got no resistance, then you touch the shaft, no reading. So that one's good. The 10SI rotor, 1 probe on one ring, probe on the other ring, 2, which was almost perfect resistance, or perfectly no resistance, should I say. Then you touch the shaft and you should get no reading. So no resistance, and then absolute resistance. Okay, the next step would be to test the trios. You basically put the probe on one part, and then where the stator hooks up, you touch the 3 prongs. No resistance, no resistance. I'm sorry, resistance. Wait a minute, maybe I should move it to where you get a better picture. I don't know if you can see it. There we go. This is the side that goes to the brush. Then you touch the 3 prongs where the stator hooks up when you hook it up to the rectifier. So 1, 2, 3, you get nothing, and then when you turn it around, you get a reading. It's not going to go to 0, but you want to make sure all the numbers are almost the same. 531, 57, 52. So that one's good. Do the other one. Two, 3, flip it around. 524, 573, 525. So that rectifier is good. I'm sorry, this trio is good. same thing with the rectifier. You got the positive bar, the negative bar, and then 3 brass straps. You have 6 diodes you need to test inside of the rectifier. Take one probe and you hold it onto the positive bar and you leave it there, and then you touch the brass or copper straps on one side. 502, 501, 504. Now you take the other probe and you hold it on the bar, and you should not get a reading. No reading, no reading, no reading. And then you do the same thing to the negative bar. Hold the probe on the bar, and then you touch all 3 straps. And if you look at the straps, you'll notice the straps are 2 halves laid down. The stud comes out of the middle of it, so you make sure you touch the right strap. You got a reading, got a reading, got a reading. Now you trade places. Should get no reading, no reading, and no reading. Okay, you hold the probe on the bar, and then you touch the straps. Reading, you got a reading, got a reading. Switch probes. No reading, no reading, and no reading. So that half is good, which is the positive side. Nice. Spin it around, you do the negative side. Hold the probe on the bar, and you touch the straps. Got a reading, got a reading, got a reading. Switch them. No reading, no reading, and no reading. So all the diodes are good. The rotors are good. Now the next step would be the stators. Now to test the stator, all 3 of these terminals touch each other right here. So you take the 2 prongs, you touch these 2, you move one over to this one to make sure you get a reading, and then you take this one, you move it over to this, and then to this. So you're going this way, and this way. And you notice you're almost getting no resistance. So now that you know all these wires are connected, you want to make sure that all these wires are not touching the stacks, which is this part. So you take one probe on the terminals, then you touch the stack with the other one, and you should not get a reading. You can touch each terminal to make sure. Okay, that stator is good. Let's do the tennis-I. Okay. No resistance. and no resistance, no resistance. And you touch the terminal and then the stacks to make sure you get no reading. That's a good stator. What this does not test is if the wires in the winding are touching each other. If you notice, there's a coating on the wire, the entire wire. That is to ensure that the wiring is not jumping from one wire to the other. If that happens, then the stator is going to test bad. When you start up the alternator, it'll make a high-pitched noise. But there is no way to test that part with the circuit tester. Not with this ohm meter, you can't do that. Okay. Both of these alternators, everything's good in them. The next step would be to show you how to set the brushes, how to rebuild the brushes. Basically, when you take apart the alternator, you're going to have these springs out of it, and the brush holder is going to look like this. If you need to, you can rebuild these brushes just by bending this tab a little bit and pulling the brush off. You'll notice there's a little notch in the brush. That little notch goes into a little indent in the brush holder. You bend this back, that way it clamps in place, and that little notch goes into that little indent. That's how you know the brush is on the right way. And it just clicks into place. Same thing with the back side. These brushes are interchangeable. You can take this brush and put it on this side and this brush on this side. This here is a grounding strap. You got to make sure the alternators that have regulators in there, the strap is in place. Now to reset the brushes, drop the springs into place. Take your pin, you make sure it's straight. Take your brush, you push it down the hole. You have a little hole on the side of the brush where the brush pin slides through, which holds the brush down. Now to get the other brush in, take the pin, you push the spring down. You lock it into place through the other hole, which holds the spring in place. Then you take the brush, you set it on top, pull the brush pin out until the brush goes down, and then push it back through the hole. And that's how you reset the brushes. A lot of times when you pull the two halves apart, the shaft is greasy, and this slides across the brushes, which puts grease on top of the brushes. You want to make sure you wipe that grease off. If you don't wipe that grease off, that grease is going to cape onto the slip ring. It's going to arc, and it's going to start building up black carbon on the ring. Now the alternator will still work, but what it does is it reduces amperage due to resistance. You want to make sure the brushes are clean to prevent that. That brush holder is already set. The next step would be to put everything back together. I'm not going to mess with the bearings. the bearings are pressed in there. To get them out, you would have to hammer them out. I don't want to do that because you're taking a chance of busting the back part of the housing. Same thing with the front. You could damage the bearing pushing it through. And the only way you would get that back in would be to hammer it, and that's a lot of hammering on an aluminum housing. So let's put these parts back together. I'm going to keep the capacitors in place. The rectifier goes in. Positive post goes in next to hold the rectifier into place. Make sure it goes into its little slot. You put the nut on, it'll hold the rectifier in place. Hand tight. Next you grab, that would be a negative bolt. For the other spot, maybe I'll grab the camera and show you this way. Put everything loose together first. Capacitor, wire, bolt. So that rectifier is in place. Let's go to the 12 SI. Positive post. Want to make sure that's good and tight. So when you put the battery terminal on, or the battery cable on, it doesn't spin. You got the two negative bolts for the rectifier. You need the capacitor screw. Okay, so you got both rectifiers in with the capacitors in place. Next thing would be regulators. A little notch goes on one side of that. Okay, the brush holder, that little slot there is where the brush pin goes through. Then it fits into place. You know it's in the right spot when little indents go into the concaves of that. Same thing here, it's got the little slot for the brush pin. Set it on the regulator. Next would be the trio. The two studs, or I'm sorry, the three studs. And then that lines up with that hole. Your two insulator bolts. Go into those two holes. Oh, this one has that. insulator bolt. Negative bolt right here. If you notice, this negative bolt's slightly bigger to fit in the hole. You can't use this negative bolt on a rectifier, it just won't fit through the hole. Negative bolt for the regulator only. Okay, basically you tighten everything down, you snug it with basically with a hand wrench. You don't want to go any tighter, you don't want to use a ratchet because you'll strip the bolts or you'll break the bolts or you'll crush the insulator if you go too tight. So I'll pause this, tighten everything up, and show you the next step. Okay, I got them all together, but I had a little accident. That one bolt that I said was negative bolt only for the brush holder, when I put it in there, I cracked the brush holder. I think what I did wrong was this brush holder was supposed to be in this one. That should have a bigger hole to accept that bolt. So what I did was I grabbed another bolt from a different alternator, made it into a negative bolt. It's actually one of these bolts. I removed the insulator, and I'll just use that. This brush holder should hold together, it should be fine. Okay, everything's tight. Next, let's talk about the stators. This is the 10 SI stator, this is the 12 SI stator. When you look at them, you'll notice a difference in the wiring and the stacks. These parts are the stacks, they're layers of sheet metal riveted together. This is what grabs the magnetism from the rotor and puts it into the wire. If you notice, the length of this compared to the 12 SI is thicker, which would mean this is picking up more magnetic saturation, putting it into the coils. That's how it gets its extra amps. The wiring is a little thicker too. This is about an 84, 89 amp stator. The wiring in this would put this about a 55 amp stator. Like I said before, these stators would be interchangeable. You could put the stator in this housing, this stator in this housing. You're just changing the amperage of the alternator. This would probably bring it up to a 63 amp alternator from a 55, and this would drop this alternator from, I think it's about an 84, 89 amp alternator to about 60 amps. And when you look at the stator, when you're seeing if it's good or if it's bad, you're looking at the wires, making sure the wiring isn't burnt. This one's painted black. That's why it looks black. And when you look at the stacks, you want to make sure the stacks are not bloated. That would be the rust getting in between the layers and spreading it apart. That would cause the stacks to dig into the wire. Next would be, you're looking at the insulating paper. You're making sure it has all the insulating paper all the way around. You don't want the stator vibrating and then the wire will rub into the stack and short out. These two look okay. They're in pretty good shape. And the insulation's missing. Nothing's bloated. Basically, you put it back together in reverse. I'll do that real quick. Same we're done, just watch. When you put the stators in, you want to make sure the wires don't hit the housing. Or the wire terminals hit on the rectifier. Put the nuts on. Snug them down. You don't want to go too tight. You'll bust the studs out of the rectifier. Okay, I'll show you what you don't want the wires to hit inside the stator. You want to make sure this terminal is not hitting the negative bar. Take a pick, slide it under and lift up. Make sure all three are like that. That was in the way. Alright, there we go. Basically take your pick, your angled pick, go underneath and make sure the wire's not hitting anything. That would cause a short. Same thing with the 10SI. If you have to, pry up. This wire right here has a habit of sticking out. You want to make sure this is pushed in. You don't want it going past the stacks. If it does, it will rub on the rotor and cause sparks, and it would short out. So you just take it and you push it back. You want to make sure where these three wires connect that it's not touching anything. That would cause a short. Same thing here. Basically feel around with the pick, make sure you're not feeling any wires behind it. Feels good. Now they're ready to go back together. Now I got the backs already done. Put the fronts together now. Set the camera down. Basically, you want to make sure the shaft is clean. You don't want to shove it into the roller bearing with dirt and debris on it. Just take something and wipe it off. Old glove. This is the 10SI rotor. And then 10SI front. fan spacer, fan, pulley, lock washer, you don't want to forget that, and the pulley nut. This is the 12 SI rotor. You want to make sure that the rotor spacer is on the rotor. Slide it in. Clean the shaft off. You don't want any debris on there. Fan spacer. The fan, pulley, lock washer, and the nut. Now you want to take your impact, tighten down the nuts. You want to grab the pulley on the outside groove. You don't want to be too close because you'll pinch your fingers when you tighten it down, and just hit it. Same thing here. Outside groove of the pulley. You don't have any debris back on there. To clean these slip rings, all you need is a piece of sandpaper. Take it in your palm and then spin the rotor. That'll clean up the slip rings. These are pretty clean. I'm not going to clean them. Set the fronts down. Grab the back. You want to orient the back, which is clock positions, up. This would be the swing arm spot. That would be 12 o'clock, 3 o'clock, 6 o'clock. Here. This would be 12 o'clock. This is where the swing arm would be. This is 3 o'clock, 6 o'clock, 9 o'clock. I'm going to set this for 3 o'clock. The swing arm hole will be up on top, and then the plug pigtail will go into the 3 o'clock position. Line up the bolt holes. Tap it apart if you have to. What's not lining up is the stator. The stator has notches for the bolt holes. You want to make sure the stator lines up with those bolt holes first before you put it together. Otherwise, through bolts won't go through. Just grab the stator and twist it in the housing. Now you see they're lined up. Try it again. Take your 2 bolts, set them in place. Let's do the 12 SI. I'm setting this one at 3 o'clock too. You want to make sure that the brush pin is pushed almost flat in the brush holder, because if this is sticking out, it will tap on the rotor. The rotor has wiring on there. It will bend that brush pin, and it could crack the brush holder. So take your finger, just push it down, And then on the back, take the brush pin and fold it over, that way it doesn't come back inside the alternator. Again, check your alignment with your stator and your back. Make sure the bolt holes line up with the slots in the stator. Set the housing down, set at 3 o'clock. Drop your through bolts in. Take a look at the back. You'll notice the brush pin is bent over so it won't go in any further. There it is. And this one, if you can see it, it's right there. I'll bend this one over so it don't go back in. You don't pull that pin out until these through bolts are all tight, and you give the rotor a good spin that it spins free. So I'll pause this video, let me tighten down these through bolts. Okay, I'm back. I got the through bolts all tightened down. After you tighten the through bolts, you want to make sure that the alternator spins free before you pull the brush pin. Otherwise, you might have to take the alternator back apart to see why the alternator is scraping when you spin it. That brush pin was hitting. Take the pin and pull it out. Spin it. Okay. You want to do it with the alternator on its side. You don't want to push that pin back in to where it hits the rotor. It's not the best bearings, but nothing's scraping. So you can just grab the pin, pull the pin out. Now that alternator is set to go. Same thing here. This one spins free. Grab the brush pin. Hear them pop. That's how you know they set. And that one's ready to go. Okay, so I got the 10 SI and a 12 SI. Tore down, everything's tested, everything tested good. I rebuilt them. Overhauled them and put them back together. So they should be ready to be tested. I'll show you how to wire these things up. If you're wiring them in a car or you're using them for something else, these alternators are real good for multi-purposing. Easy wire hookup. Like I said, if you know what you're doing, you could hook them up by 2 wires. The battery wire, which would be a 10 gauge, goes to a battery, and then terminal 1 and terminal 2, you could take terminal 2, which is voltage sensing wire, and you could attach it right to the battery wire, because on a car, this red wire eventually makes its way back to the battery anyway. So you could cut that wire out and just loop it to the battery. I have a switch panel here that I wired up for my APU, and I'll show you what I mean. This is the pigtail. Goes into the plug. And then the red wire on the pigtail, which is terminal 2, the bottom one, can go right to the battery terminal. and then you would take a wire from here to the battery to charge the battery. And then the white wire would be keyed ignition. You really don't even have to have a light on that circuit to make it work, as long as it's 12 volts. It will turn the alternator on, and when you shut the car off, it'll turn the alternator off. Or, like I have it here, I have it hooked up to a switch. That would be on, and that would be off. The light would come on when the engine's not running on the APU. When I start the engine, the light will go out, showing the alternator's working. And then the switch panel attaches to the bracket hole in the back to ground out the panel. I have one more thing to mention. There's a slot on the back of the alternator. The slot is for testing the alternator, which is this hole right here. This hole. The idea is to take a small screwdriver, push it into the hole till it stops. Where it stops is on that brush holder. The brush itself, you're touching the brush, which would be the bottom bolt with the insulator. You're bypassing the regulator, since the rotor is controlled by the regulator through the negative wire. What you're doing, you're taking the screwdriver, you're touching that brush, and you're grounding it out on the case to bypass the regulator. And what that does is full fields the rotor, and it makes the alternator go to full output. Now, you don't want to do it for a long time, because you can heat up the alternator and blow something like the rectifier, or you could blow or burn up the stator or the rotor. What I plan on doing to this alternator, this one came off of my APU. I'm going to take this back apart, put a ring terminal on that insulator, and run it through the housing to hook it up to a switch, because the only way, if you're jumping a car, you have to full field the alternator to start the car. If you don't do that, it'll just charge the battery up, and it'll stop charging when it reaches the voltage requirement, and it won't cram any more electric into the battery to where it would be able to start the car. So you would want to bypass the regulator, and I don't want to do that by using a screwdriver or a piece of steel while the thing is running. I could miss it, jam it too far. That would fuck something up. So that concludes rebuilding these alternators. I'd like to thank you for tuning in. I was on YouTube the other night, and I noticed I have 1 subscriber. Alright, I don't know who you are yet, but I'll find out. Thanks for watching, and hope you learned something. Bye. Oh, one more thing before I go. Part 3 is going to include me testing these alternators on my APU. I'm going to hook it up to my Jeep. I'm going to show modification you could do to the stators to increase the amperage just by rewiring the stators. I have a third stator here. This is about a 40 amp stator, 10 SI. I'm going to turn this 40 amp stator into probably about a 63, 70 amp stator just by rewiring it. I'll show you how to do that in the third part. I'm going to try to scrape up an amp gauge to where I'm going to do that modification to this alternator. I'm going to test it first with the stator that's in there. It should be about 50 amps. And then I'm going to swap out the stator. This is a skinnier wire stator, so it's about 40 amps. I'm going to test it to confirm that it's about 40 amps, and then I'm going to rewire it with the amp gauge on there to show you that the modification does work. This modification, the factory alternators nowadays come already wired that way. They must have caught on. They caught on the next generation of alternators, because that's when they started doing that. So click on the comments, make a comment, tell me how I did, like it, hate it, let me know. I look forward to it. Bye.